Welcome to the deep dive. Today we are tackling, well, probably the most fundamental and personal question in all of science: consciousness.
It's the big one.
It really is. I mean, why do you feel like you?
Hmm.
It's this mystery that we haven't solved with just, brute force. Cognitive science is great at mapping the contents of your consciousness.
Your thoughts, feelings, what you see.
Exactly. But it's still fiercely debating the core purpose of it, or even if it has one.
And that debate is, it's incredibly high stakes right now. You've got these powerful established theories.
Like global workspace theory, GWT.
Right, GWT, which is a great metaphor, sort of a theater of the mind.
Yeah.
And then there's information integration theory, IIT, which tries to actually quantify consciousness with a metric called phi.
The stack of sources we've brought in today offers a really radical critique of all that. They argue that theories like GWT and IIT, they often lack a role for something fundamental to life.
It's purposiveness.
It's intrinsic purposiveness, and they hit really hard at another very popular trend: predictive processing.
Yes. The prevailing idea there, and it is everywhere, from neuroscience to AI, is that life is all about predicting sensory input, that we're constantly building these internal models to guess what's coming next.
To keep things stable, right, allostasis.
Exactly. But what's the problem with that?
Yeah, what is the problem?
Well, the source material suggests these prediction models, as elegant as they are, they just fundamentally struggle when the world is chaotic, when you're facing multiple, novel, and completely unpredictable disturbances at the same time.
Your prediction model just falls apart.
It breaks down. They point to robotics, for instance. Devices that use these complex predictive models, they consistently need these underlying hardwired negative feedback control systems to actually function in the real world. You just can't predict everything. Sometimes you just have to react.
So our mission for this deep dive is to distill this radical alternative. It's called perceptual control theory, or PCT. We're going to show you how PCT defines purpose not as prediction, but as control of your own experience.
And how that one simple idea can explain everything from, say, getting stuck in conflict to how you learn a new skill.
Okay, let's unpack this core idea because it sounds simple, but it's pretty profound. PCT claims that purposiveness isn't about looking into the future. It is fundamentally about the control of input.
It's about the organism acting to keep its perception of the world exactly where it wants it to be.
Yeah.
And that's the first kind of mind-bending realization.
Which is?
This control comes before consciousness. You don't need to be consciously aware to have purpose. To get our heads around that, we need to define the core mechanism, the negative feedback loop.
Right, the classic analogy, the thermostat. But let's be really clear about the parts. So the thermostat has a setting, say 70 degrees. That's its desired state.
That's the reference value. We just call it R. That's the goal.
Okay, GLAR. Now, the system compares that goal, 70 degrees, to the current reality.
The perceptual signal, or Andy, maybe the room is actually 65 degrees.
So the mismatch between those two 70 and 65, that creates what they call the error signal.
E, which is basically the system saying, Houston, we have a problem.
And that error signal drives the action.
Exactly. The system generates a continuous action, the output quantity, or
turning the furnace on.
Turning the furnace on, yeah, to counteract any disturbances, like an open window, a draft, whatever it is. And the genius of it is that the system doesn't need to model the future or predict the draft. It just acts in the direction that will oppose the present time error.
And this is the crucial part, this whole process of sensing, comparing, acting.
Yeah.
It all operates outside of conscious awareness.
Completely. It's what allows you to, manage 99% of your life without having to micromanage every single muscle movement.
Yeah.
In this theory, behavior is just the control of input.
Hold on, let me just challenge that for a second. If my actions are just continuously correcting error signals based on these preset goals, these reference values, doesn't that sound completely deterministic? Where's free will in any of this?
That's the big philosophical hurdle, for sure. But PCT doesn't necessarily reject free will. It redefines it. The sources argue that while your behavior is determined by the system structure, you have immense control over which perceptions you choose to control your settings. And as we're about to see, you also control the structure of the system itself. So your freedom isn't being a controller, not a predictable machine.
The freedom to choose what you care about, I can work with that.
Exactly. And what you choose to care about, what you control, is organized in this amazing structure that power is called the hierarchy of perception. Just picture a vast branched root system in your mind.
Okay, so at the low levels, the roots, the perceptions are simple, continuous things.
Right. The intensity of light, pressure of your foot on the floor, the feeling of warmth.
And as you go up the hierarchy.
The systems organize inputs from the levels below them to specify more and more abstract perceptions. So a complex pattern of light and sound becomes the perception of a door opening.
And at the very highest levels, you get things like abstract principles, like honesty or kindness, and even system concepts like your own self-identity.
Exactly. And what's so fascinating is the theory suggests that these different levels, they actually approximate our recognizable conscious experiences.
Yeah.
They become what we call qualia.
So the color red is just a low-level perception, while the feeling of injustice is a really high-level one.
But they're both just variables the system is trying to keep at a specific reference value.
Yeah.
It's an incredibly unified way to look at our subjective experience.
So if all this basic control is happening automatically through this hierarchy, and we don't really need consciousness for moment-to-moment survival, why did it evolve? What is its job?
That is the key question, and this is where the theory gets really interesting. Consciousness isn't about running the system day to day.
It's about what?
It's about fixing it. Its primary function is to be the engine of change, a process called reorganization.
Reorganization. So it's generated and sustained when you're trying to reduce some kind of persistent, uncorrected error.
Precisely. It's the adaptive trial and error tweaking of the control systems themselves, changing their functions, their parameters, their connections.
But only when there's what the theory calls intrinsic error.
Right, and let's just simplify that. Think of intrinsic error as the non-negotiable survival signals. Deep hunger, intense pain, the need for safety, a severe imbalance in your blood glucose.
The really important stuff.
The stuff that evolution has hardwired you to care about. When control breaks down on those essential variables, that is what grabs consciousness.
So if my low-level control system for, I don't know, keeping blood sugar stable is stuck in error for a long time, consciousness is literally drawn to that spot in the hierarchy.
That's the idea. And while your conscious awareness is focused there, the reorganization process kicks in. It allows for these random trial and error changes to that specific control unit's properties until eventually the error goes down. It's like a rapid form of natural selection happening inside your own mind.
Wow. Okay, that's a powerful way to think about solving complex problems, like conflict resolution. How does PCT define conflict?
It's a very elegant definition. Conflict isn't about two competing actions, like should I move my left arm or my right arm. It's about two or more control systems setting different reference values for the very same perceptual variable.
Can you give us an example?
The classic one is the avoidance approach conflict. You want to get close to a spider because you're curious. That's reference value 1, proximity.
Right.
But you also want to get far away because you're scared, reference value 2, distance. So the person just sort of oscillates. They lean in, they pull back, they're stuck.
It's a feeling I get when I look at my to-do list. I want to start the project. That's my R for achievement. But I also really want to take a nap, my R for comfort. And you just bounce between the two, doing nothing.
You're burning energy without solving the problem.
Yeah, exactly.
And the solution isn't at that low level of action. You resolve that stuck state by controlling a higher level, a superordinate perceptual variable.
You have to introduce a new goal.
A new reference value, like the principle of bravery with the spider or self-discipline with a to-do list. That new higher goal acts as a balancing force that allows you to manage the two conflicting lower goals. But that kind of high-level shift, that requires sustained focus.
It requires conscious reorganization.
It does. And you can see how this explains why something like therapy can work. It helps you shift your conscious awareness above the immediate conflict to establish that new superordinate goal. You're not trying to force the behavior. You're changing the reference values that drive it.
Okay, so this whole system is made even more powerful because PCT includes local memory in each control unit. And this lets the system operate in 4 distinct modes.
Right, and these modes map pretty cleanly onto conscious experiences we all recognize.
Okay, let's run through them. Mode 1 is controlled.
This is when you're fully engaged. All signals up and down the hierarchy are active. Think about learning a complex piano piece, focusing on every single note, every finger placement, high awareness, constant error correction.
Then you have mode 2, automatic.
This is when your lower level systems are just running off stored memory. That experienced pianist playing a familiar song, their fingers are moving automatically, which frees up their higher level attention for something else.
Like passive observation. Mode 3.
Exactly. Passive observation. You're taking in sensory input, perceiving, but you're not sending control signals down to act on the environment. You're just watching a sunset, letting the inputs come in.
And finally, mode 4, Imagination.
which is an internal mental simulation. You're rerouting memory and treating it as if it's current perceptual input
And why do we do that?
to reduce error internally when you can't interact with the real world. You're prepping for a tough conversation, so you run through it in your head over and over, tweaking it until that expected error signal goes down.
And what's really important, I think, is that different parts of your hierarchy can be in different modes at the same time.
Oh, absolutely. You can be automatically driving a familiar route, passively observing the traffic, and in fully controlled mode planning what you're going to make for dinner, all at once.
This all leads to maybe the most unique part of the theory, about consciousness itself. The idea that consciousness is sustained by controlling the information integration rate, or IIR.
This is a really crucial distinction. We mentioned IIT earlier, which measures how much information is integrated. That's phi. But PCT says the organism is intrinsically motivated to integrate information at a self-governed rate.
So it's not about the amount, it's about the speed of integration. And we're trying to keep that speed at our own preferred level.
Exactly. The IIR is an endogenously controlled variable. We are constantly working to keep the rate of new information absorption at an optimal reference value for us.
Wow, that completely reframes the purpose of consciousness. So how does controlling the IIR explain things in our daily lives?
Well, let's start with continuity. If you're successfully keeping your IIR constant over time, that accounts for the normal, smooth, continuous feeling of conscious experience.
But the exceptions are more interesting. You hear stories about time distortion, right? In a car accident, people say everything slowed down.
That's explained by an exceptionally increased IIR. When your intrinsic systems are suddenly thrown into a high error state, a life or death moment, the system ramps up its integration rate to process the absolute maximum amount of information for survival. And that leads to the subjective feeling of time slowing down.
That's fascinating. And it can even explain something as simple as curiosity.
It does. Things like curiosity, exploration, play, they emerge as behaviors to maintain your optimal IR. If your IR is dropping because your environment is too predictable, you go out and seek novel perceptual inputs to keep that rate up.
You're chasing novelty to maintain that optimal mental state.
And conversely, if the system is getting too much complex, unintegrated input, it will try to reduce the IRR to a more manageable level.
And that would explain avoidance behaviors.
Yes, you might do that by focusing on simple, repetitive things, or avoiding complex environments, or engaging in rituals. The source material draws a parallel here to some of the behaviors we see in conditions like autism, where the sensory world can be intensely overwhelming.
So pulling it all together, that feeling of being in the zone, the flow state, is that just successful IRR control?
In PCT terms, it's the feeling of successful reorganization. The moment you figure out the optimal control structure for a task, you've solved the intrinsic error and you've optimized your IRR. That subjective experience is the feeling of flow.
Okay, so now we have to move to the human layer, what the theory calls secondary consciousness. Because we have language, long-term planning, this is another level of complexity.
That is. And to account for this, PCT introduces propositional systems.
This is where we stop controlling direct sensory input and we start controlling symbols.
Right. Humans use symbolization language, logic, semantic knowledge as a kind of order reduction method to represent and talk about specific perceptual variables.
So these propositional systems they're separate from that core perceptual hierarchy we talked about.
They are. They're essentially where all the beliefs and models from predictive processing theories would live. They represent the world through syntax and agreed upon rules, not just raw sensory data.
And this just changes the game for conscious control. Because we have symbols, we can now sustain a perception in our consciousness just by, say, repeating a word or writing down a thought.
But more importantly, we can direct the focus of our awareness, that engine of reorganization, independently of whether there's any intrinsic error present.
And that's critical for systematic learning.
Absolutely. Think of a sports coach. They tell you, focus your awareness only on keeping your head still. Your current performance isn't causing you physical pain or anything.
There's no intrinsic error.
Right. But you use your propositional understanding of that instruction to direct reorganization to that one specific variable. It's how we learn skills systematically, outside of just pure survival.
So the big challenge for human consciousness, then, is this constant switching between our intrinsic needs, our biological demands, and our propositional rules and plans.
The cultural values, the long-term goals. And when they work in synergy, it's great. The propositional system gives us a framework to learn new roles, maintain abstract values.
But where does the conflict come in now?
It's when the propositional goals The agreed-upon facts or plans clash with an individual's intrinsic goals. You know you should exercise, that's the propositional
Yep.
plan, but your intrinsic system for controlling comfort and effort just overrides it every single time.
So you only control the symbols. You talk about exercising, but you don't control the actual bodily sensations of doing it.
You get that classic gap between theory and implementation. It's not a lack of willpower, it's a conflict between two different control systems. The ultimate claim is that adaptive human life requires this ongoing cooperation between our intrinsic systems, our perceptual hierarchy, and our propositional systems,
We're trying to be a universal perceptual control system.
using language and culture to expand the world we can control.
That's a fantastic place to wrap up our deep dive into perceptual control theory. It reframes consciousness not as some passive theater of the mind, but as this focused engine of reorganization.
All driven by the need to control our inputs, and specifically the rate at which we integrate new information.
And this integrated model, it really does explain so much. From why you feel flow when you're learning something new to why you might avoid an overwhelming situation.
And its application in psychology is so direct. It gives you a roadmap for resolving conflict by shifting your conscious awareness to those higher-level goals, those principles like bravery or honesty, to resolve that deep-seated error.
The implications are they're profound. If consciousness really is a mechanism designed to optimize our control systems, if we can map it to something physical, like the alteration of parameters in a negative feedback loop.
Then we can test it. And research proposes we can do exactly that. Imagine a simple tracking task. You're using a joystick to keep a cursor on a target. If we just tell you to shift your focus from the cursor's position to the feeling of effort in your hand, we should be able to measure a corresponding change in the reorganization rate in a computational model of your control system.
We could literally see consciousness at work.
We could. And if we can map consciousness to a quantifiable system property, what does that mean for the ultimate boundary between mind and machine?
Something to mull over until our next deep dive.